Hello everyone, I welcome you all to this course certification in quantity surveying. We are calculating the quantities related to the various components. So this is another different component that we have considered for this module. The component is a false ceiling. Let us first of all see what exactly the false ceiling is all about. Then we will be calculating the quantities that are related to the false ceiling calculation. So this is not part of concreting or shuttering or anything. This is a purely different component we have. So let us start with knowing what exactly the false ceiling is all about. Now false ceiling is a fitted ceiling that hangs below the original ceiling of the room or a home. It is usually suspended by wooden or metal frames, and the illusion brings that to the lower ceiling. So now, as you are able to see, the main ceiling over here is this wooden one, and the other ceiling that is in the process of providing with the help of this bars or the angles is the false ceiling. Okay, so now what exactly is the purpose of the false ceiling? First of all, it adds the aesthetics to the room because whatever the that this gives the finishing properly. What happens sometimes the concreting slab has been casted in a very hurry or in a rough services, so it won't gives you a nice aesthetics look. So after finishing, as you can see at the bottom image, the room is really giving an enhancing look, and the white color is putting another grace into that room. Then it helps in the thermal insulation. So now what already discussed, it hangs below the original ceiling, so there is a kind of 1 to 1.5 meter 1 to 1.5 feet difference between the main ceiling and this false ceiling. So there this is a this distance provides you the great thermal insulation itself. Then it hides the wiring and unwanted electrical fixtures. As you are able to see into this first image, there are lots of wiring, then electrical conduits, AC conduits, and etc. Even sometimes when I want to fix a bulb or tube light as a fixture, they do have their own fixtures with them, so they don't look much nice and aesthetically good. So we can hide them into this one. As you can see in the lower image, there are no wires hanging, there are no fixtures over here. There's plain surface with only the lightnings, the window which is given, which is very nice in aesthetics. Also it helps you to hide unwanted offsets and structural components. Now sometimes what happens, there are sometimes beams or offsets of the column which don't go in a grace with your room, so you need to hide them somewhere. You just need to put them under something, and that is where this false ceiling is going to help you with. So let us see what are the various types of false ceiling, what are their advantages, disadvantages, and where they are best suited. So the first one is a POP, that's a plaster of Paris, which is very commonly used false ceiling, and which is the advantage of which is it's a durable and aesthetically it's a really good. The only disadvantage is it has a loss of cast in situ work and a more hectic work also. So now what happens, I have to mix the POP into this nice paste I have to make, then I have to make that jali or net I have to fix, then I have to apply it, then the finishing work goes on, and that takes lots of time. Along with it, the casting process of this one is very tedious one, a clumsy one. So that is the only issue we have with the POP, and it's best suited for the residential purpose. As you can see, it's kind of a cheaper material we have, so it's a residential people refer to go with this one mostly. Then next one we have is a gypsum boards. Gypsum boards, they have a more enhancing looks, they are smooth in finishings. They the cast in situ work is really less, as there are these boards are directly ready to be casted. Just to be you need to cut them down into proper shapes whatever you want, and you can fix them. Okay, then they are very easy and fast to install, and then it has a cost which is kind of lesser as compared to the POP. Then the only issue they have is a joints in between these boards. Now this, as we have told, this board, gypsum boards, they are long one boards, and we have some joints in between them, and because of the heat, or sometimes if earthquake occurs, these boards joints may get separated, and yeah, it might even has a chances of falling it down. So that is the only issue related to joints you have. Then you just need to go on fixing that joint again whenever it causes a trouble. It is good for shops and offices. The next one and most commonly used one is a grid ceiling. Now what exactly it is, it's a very easy to install, it is removable and it can be reinstalled. Now what we have seen in the first image, it's a grid ceiling, that wherein we make a grid of the angles and we just put these sheets, these are the white sheets, if you are able to see, we just put these sheets in between those two grids just by simply pressing them into this one. If I want to remove them, I just lift it sheet, I take that sheet out and I can fix the, I just take out those angles also and I can fix them and move them to anywhere. So this is a much simpler way of doing a false ceiling. The only issue they do have is related to the moist environment, they don't react properly. And they are good with anywhere, studios, workshop, offices and rented facilities most of all, because if I'm renting a facility, I should be in a position to take out that whatever material I am going to put in, just I'm going to remove it and take it with me whenever I'm going to shift to the other property. Then we have a wooden plastic composite, that's a WPC, which is the main importance of this one is it's a waterproof anti-termite and that's what is needed in a balconies and bathrooms and residential where the moisture is more in those places. So this is another component which is being using most of, widely these days, which is, but it's a kind of costlier as compared to this above other methods of the false ceiling. Then the last one we have is a wooden ceiling. It's a really great and aesthetical work. So yeah, wood is a really can be crafted into different shapes, and the more importantly, the wood has its own grace look. So aesthetically, it looks really great, and that can be used with the other combinations. You can use the wood plus POP, wood plus grid gypsum boards. That combination goes very nice into the houses. The only issue, and that's the biggest issue we have related to wood ceiling, is a moisture, and it's great for the residential purpose. Okay, so now with this, let us start measuring how am I exactly going to calculate the quantity. Now for this calculation, I have considered a grid ceiling as it is most widely used these days. So let us calculate the quantity for the grid ceiling and everything. Okay, so now let us first of all understand what exactly we are going to do. The first thing that we need to know that the grid sheets that we are mostly available are of size 2 by 2 feet. Okay, so these are the very common sheets as you are able to see into this one. The size of these sheets is most of the time 2 by 2 feet, and they fit and they look aesthetically really nice, so they are commonly used. So we are going to fix into the room of 12 feet by 10 feet room. So for that, how am I going to calculate the quantities of these sheets along with the bars or the angles they are going to be resting on? So that quantity I'm going to calculate. So what exactly they are? So these are the sheets that I have already told you, and these are the angles, or may call it the main angles and the distribution angles we have. So how am I going to calculate these quantities? Let's see. Now let us first of all find out the area of the soffit. So what exactly is soffit? Soffit is an internal room area, that's from end to in area, the area in which we actually need to fix the false ceiling. That's the area of the soffit. Okay, so what's the soffit area given? It's a 10 feet by 12 feet, so 120 square feet is a total area that has been given. Okay, then the area of one standard sheet is 2 by 2, that's a 4 square feet. Okay, these two points now we do have. So now can we calculate the number of sheets that we are going to need? Yes. Total number of sheets, how am I going to calculate? That is a soffit area divided by one sheet area, that's equal to 30 sheets I am going to need for fixing this whole 10 by 12 square feet area. Then now I am going to calculate the angle bars main and distribution bars. Okay, so in your case you can define any angle bar as a main or distribution bars. Whatever is defined as main can be defined as distribution. There is no specific definitions of this one. So in our case, let us consider horizontal to be the main ones and the vertical to be the distribution ones. Okay, so how am I going to calculate their quantities? Now the total length of the main angle bars. Now how we have seen, the main angle bars are the one who are the horizontal ones. Okay, so they have the length of a 10 feet, that you need to remember. So now length of the ceiling divided by spacing of the sheets. Okay, so now what is the length of the ceiling? That's a we are calculating, first of all, do remember that we are calculating the total number of main angle bars. Okay, so number of main angle bars is how many main angle bars? 1 2 3 4 5 6 7 I'm going to need. So main angle bars are the horizontal ones. So now the where the horizontal bars are serving, they are serving to the vertical length, right? They are perpendicular to the vertical length, so they are in a perpendicular means what, they are serving for the vertical length. So that's why to calculate their quantity, the quantity of the main angle bars, I need to have the length of the ceiling. That's the vertical quantity. Are you able to get it? Yeah. So based on that, let us see, length of a ceiling I need to have divided by spacing of sheet. Again, if you wish, I'll just repeat it. So we are calculating the total length of a main angle bars, and who are the main angle bars? They are the horizontal ones. So to whom horizontal ones are perpendicular to the vertical, right? So these horizontal bars, if I want to calculate, I need to calculate, know the length to whom they are serving. So that's a vertical. So that's why length of a ceiling is considered, that's a vertical one, divided by spacing of one sheet. So that is 12 divided by 2. That comes out to be 6. Now why this plus 1? Now just a simple example. If I want to draw a 3 by 3 square, okay, 3 by 3, then I have to draw in total 4 lines, if you are able to get it. So now this line is 1 2 3 and 4 lines, 1 2 3 and 4 lines. To draw one square, you need to draw 2 lines. To draw 2 square, you need to draw 3 lines, right? 1 2 3. So you always need to add plus 1 into this while calculating the quantity. Okay, so that's why we have added this one as a 7 angle bars. Okay, so next one, now the total length of main angle bars, we have calculated the numbers. Now with the help of numbers, we just need to multiply this by this actual length of them, that is a 10 feet. That is width of the ceiling, that's a 10 feet, into number of bars, that is a 7, that comes out to be the 70 running foot. The next one we have is a total number of the distribution angle bars. Okay, so now how am I going to calculate? Now we have already discussed that horizontal bars are the main angle bars and the vertical bars are the distribution ones. So how am I going to calculate the distribution angle bars? Now for that, I use the length of the ceiling. For this one, I am going to use the width of the ceiling. So with the width of the ceiling divided by spacing of the sheet, that's 2 feet, plus 1, that comes out to be the 6 angle bars I am going to have it. That means 10 divided by 2 plus 1, that's a 6 angle bars. Now the total length of the distribution angle bars, how am I going to calculate it? That's the length of the ceiling, that means, and into number of distribution angle bars. The same one that we have done in the previous one, we are going to do it in over here also. That's 12 into 6, I'm going to get 72 running feet. So now what I need to do is just to add these two quantities that I have calculated, total distribution angle bars and total main angle bars length summation, that's equal to 70 plus 72, that's a 412 running foot. So for the room of 10 by 12 feet, I need to have the quantity of the 2 by 2 sheets to be 30, and the total distribution bars and the main angle bars comes out to be the 412 running feet. Okay, so with this I wish you all the best. Thank you so much.